Good afternoon, students. We'll start with the new topic today, that is isomerism. Okay, we have finished with GOC and we will understand more about isomers that are present in organic compounds. Isomerism is obviously a phenomenon of exhibiting isomers. So let us understand what are isomers. Isomers किसको कहते हैं? So isomers are two or more compounds with same molecular formula but different in properties. They will differ in properties. So we have to write the definition of isomer. So isomers are going to be two or more compounds which share the same molecular formula, but they differ in their properties. And this phenomena of exhibiting isomers is called as isomerism. तो isomers का हमेशा molecular formula same रहेगा. तो say for example, I'll take a formula C2H6O. This is a molecular formula, and I'll be writing two compounds who are having the same molecular formula. One compound with this molecular formula is C2H5OH. So this is ethyl alcohol. And another compound with the same molecular formula is CH3OCH3. This compound is dimethyl ethyl. And you can clearly see that these two are different. They are having different functional group. This is alcohol and this is ether. So obviously they are going to differ in their chemical properties. Their physical properties are also different. This is liquid at room temperature and dimethyl ether is a gas at room temperature. So what we see here is there are two compounds on the board which are just sharing a molecular formula common. They have a different structure, they have a different property, and these kind of compounds are called as isomers. And this phenomena of exhibiting isomers is called as isomerism. Now we will classify isomerism, okay, further into two categories. I'll clear the board and explain you what are different kinds of isomerism. If we can also classify isomers into different categories. Either way, it's one and the same. So isomers के अलग-अलग types समझ लेते हैं. So mainly two types है. I can classify isomers into two types: structural isomers and stereoisomers. So what are structural isomers? Obviously, these are the two compounds which are going to have molecular formula same, but they will differ in their structure. They are also called as constitutional isomers. Another name to structural isomer is constitutional isomers. their constitution is different. So structural isomers are going to have same molecular formula, but they will have difference in structure. And due to difference in structure, they will have different properties. The example that I gave you just now, ethyl alcohol and dimethyl ether. Okay, they are constitutional isomers. They differ in their structure. And because of that, their properties are going to be what? Different. And the another category is stereoisomers. So I'll discuss that later. Let me first explain you the different types of structural isomers. The structural isomerism, okay, is further classified into various types. So we can have various kinds of structural isomers. The first type of structural isomer that we have is chain isomer. The second type of structural isomer that we have is position isomer. And the third type of structural isomer that we are having is functional isomer. The fourth type is metamers. The fifth type is ring chain isomers. And the sixth type is tautomers. There are 6 types of structural isomers which we will see in detail. हम इसको detail में पढ़ेंगे. Okay, but let us broadly understand the difference between structural and stereo at this stage. So what is a stereoisomer? Two stereoisomers definitely have same molecular formula. Their molecular formula is same. And their arrangement of structure is also same. Their structural part is same. Their IUPAC name is same. When I say same structure, okay, means their IUPAC name is same. But they have different arrangement of groups in 3-dimensional space. So if you look in 3D, the arrangement of atoms around the carbon in 3D space is different. So they are having different arrangements of groups around carbon. But still the structure and the IUPAC name will remain same. And then because of that, obviously they will have difference in properties. Which properties will be different? When we talk about structural isomers will differ in physical property as well as chemical property. Okay, as they totally have different structure. But when we go to stereoisomers are going to have same structure. Okay, so functional group wise they may be same, and because of that they are the one which can have same chemical property, but they will differ in physical property. So difference in property comes in stereoisomers and that will be mainly in physical property में इनके फर्क होगा. Okay, but ये सब हम और डिटेल में करेंगे as we go ahead. अभी स्टीरियोआइसोमर्स का क्लासिफिकेशन देखते हैं. Stereoisomer is further classified as configurational isomers and conformational isomers. So what is configurational and what is conformational? We will see this in detail when we will actually check with stereoisomers, but just at this stage to make you understand the difference. When it is configurational isomers, two isomers cannot get converted into each other simply by rotation of a bond. Okay, simply by rotating a molecule along a particular bond, we cannot get an interconversion of one isomer into another. And in conformational isomerism, the two conformational isomers can get changed into each other. Okay, simply by rotating a bond. So here interconversion between two isomers possible by rotation of carbon-carbon bond, and here interconversion between two isomers is not possible simply by rotation of CC bond. ये point में फर्क है. Okay, now let us see their further classification. The configurational isomer is further classified into two types: geometrical isomers and optical isomers. Okay, so these are the different types of isomers possible, and exhibiting them is the phenomena called isomerism. So this is what we are going to cover basically in this chapter, isomerism. So I will first start discussing structural isomerism, and then we will start discussing stereo, in which there are mainly three categories: geometrical isomers, optical, and conformational. Okay, these are the three categories that I have to discuss with you. Okay, in case of stereo. Stereo isomerism will be the main part in isomerism chapter, and which is quite linked to the topics coming ahead, reaction mechanism and topics coming ahead. Okay, always a common question comes: how many isomers are possible? Or in the given reaction, how many compounds are formed? And in which we have to count the isomers and write the answer. So whatever we are going to do in this topic, isomerism definitely is very much required in chapters to come ahead. So please copy this. Okay, and I'll start with structural isomerism. So I'm clearing the board and let us start with structural isomerism. So first type is chain isomerism, also called as nuclear isomerism. So what is chain or nuclear isomerism? In this type of isomerism, okay, there is a difference in arrangement of atoms constituting the carbon chain. They are differing in the carbon chain. So two chain isomers will differ in arrangement of carbon atoms constituting a chain. Say for example, I take a formula C4H10. I am giving you alkane with this formula. This is N-butane and a chain isomer of N-butane, where there is a difference in carbon chain is isobutane. So N-butane and isobutane, okay, differ in carbon chain. Here there is a 4-carbon straight chain and here 3-carbon chain with a branch of methyl group. Is the point of difference, okay, between the two chain isomers. तो चेन आइसोमर कैसे आइडेंटिफाई करना है आपको? चेन आइसोमर में कार्बन के चेन में फर्क होना चाहिए. So I'm taking the next formula C5H15 and showing you some chain isomers with this formula. So you can have 5 carbons in straight chain, N-pentane, isopentane, and neopentane. Okay, so these three you can check what is the difference between them. The difference between them is in carbon chain. They are differing mainly in their carbon chain. Now, does that mean only alkanes can have? No, any functional group you pick up and you can get chain isomer there. So I'm just showing you some more. Okay, the next formula that I'm picking up is of alkene, C4H8. With this formula, I can have 4 carbons in straight chain, 1 butene, या ब्यूटिलीन, कॉमन नेम लिखना है तो ब्यूटिलीन, और इसका चेन आइसोमर होगा आइसोब्यूटिलीन. differ in carbon chain. Then we can take some other functional groups other than hydrocarbon. So I can take a 4-carbon alcohol, C4H10O. So 4 carbon straight chain and OH1 carbon number 1. Common name may we call this as N-butyl alcohol. And what will be the chain isomer of N-butyl alcohol? I need to make a difference in carbon chain. And what we get is isobutyl alcohol. Then, so does that mean only aliphatic compounds can show us chain isomerism? Answer is no. Now I'll show you some alicyclic compounds showing chain isomerism. The next formula that I'm taking is C6H12. So here a better word, nuclear isomerism, can be used. So C6H12, this is your cyclohexane. And then a chain isomer of this, where the ring members have changed, and is methyl cyclopentane. So cyclohexane and methyl cyclopentane are chain isomers of each other. And then I can go on writing more. So dimethyl cyclobutane or trimethyl cyclopropane. Okay, these are the chain isomers of each other. They all are having same molecular formula. They are differing in structure with respect to carbon framework, carbon present in the ring. So this is what is your chain isomerism, where two isomers will differ in their arrangement of carbon chain. So copy this and I'll explain you the next one, position isomerism. So I'm clearing the board and we will see now the next isomerism in structural, and that is position isomerism. So what is the difference in two position isomers? They will differ in position of functional group, or maybe a double bond or a triple bond. So position isomers are going to be different in position of functional group or double bond or triple bond. So let us take examples now. So I'm taking a formula C3H8O, a 3-carbon alcohol where OH group is positioned on carbon number 1. Common name N-propyl alcohol. And a position isomer of this where the OH group is positioned on carbon number 2. This can be called as sec or isopropyl. So these two are not differing in their carbon framework. They are having 3 carbons straight, 3 carbons straight. But the only difference that we see is in position of functional group. Functional group is present on different carbons. And they are position isomers of each other. Common name of this is N-propyl alcohol, and this is isopropyl alcohol. Let us see some more examples. So I take a double bond containing position isomers now, C4H8. So you can have a 4-carbon alkene. This is your 4-carbon alkene, 1-butene, your but-1-ene, where position of double bond is on carbon number 1. And this is but-2-ene, where position of double bond is on carbon number 2. And these two are position isomers of each other. Okay, I'm taking the next molecular formula, C6H6O2. This is the aromatic compound that I'm discussing. It's a phenol, or these are hydroxyphenols, where the two OH groups can be 1-2 at 1-2 position. तो इसको ऑर्थो पोजीशन भी कहते हैं, या इसका जो पोजीशनल आइसोमर होगा उसमें रिंग पे OH ग्रुप की पोजीशन चेंज हो जाएगी. So if I write 1-3, what are these two of each other? Position isomers. And see the next. Okay, so I give you some examples of position isomers. I'm putting up some compounds on the board which are having same molecular formula. And I want you to tell me the isomers in that formula. try writing how many isomers you can get with this formula. So see what are the different isomers possible with this formula. So 6 carbons in straight chain, ये वाला एक isomer हो जाएगा ना. What will be the other? Now let's put 5 carbons in a chain and a branch. Right? 5 carbon in a branch. So वहाँ पे मैं 5 carbon framework में तो branch that was at position 2 वो 2 methyl pentane था, ये हो गया 3 methyl pentane, and now I can have 4 carbons in straight chain in which there will be 2 branches of methyl group and 2 branches of methyl group on same carbon. So these are the different possible isomers with the formula C6H14. So we need to do little bit practice of writing this number of isomers. They can give you a formula and ask you to write benzene derivative. How many benzene derivatives are possible? तो ऐसे क्वेश्चन में क्या करना होता है कि जो भी आइसोमर्स हम लिखेंगे सब बेंजीन के ही डेरिवेटिव होना जरूरी होता है. So I'm giving you the next formula. C9H14. And you can write benzene derivative for that. बेंजीन डेरिवेटिव में C9 दिया है, तो 6 कार्बन्स तो बेंजीन रिंग में चले गए and 3 carbons outside, which I can put like this. This is N-propyl that I have. And benzene and 3 carbon outside में और एक variation possible है. I can attach it as isopropyl. So this is the compound that is also called as cubene. फिर अभी next क्या करेंगे हम? Okay, we will break these 3 carbons as 2-1. तो फिर एक ग्रुप हो जाएगा इथाइल, दूसरा हो जाएगा मिथाइल. और फिर इसके पोजीशन आइसोमर्स बनेंगे 1 2 1 3 1 4. So this is, I'm having 2-1 split. और क्या हो सकता है? I can have 3 methyl group present. So all the 3 methyl में क्या क्या variation हो सकता है? All the 3 methyl में ये 1 2 3 position पे present हो सकता है. 1 2 4 position पे present हो सकता है. या ये 1 3 5 position पे present हो सकता है. And there is no other variation possible. Okay, so these are some benzene derivatives that I have written on. अभी what are they of each other ये समझना है, तो मैं इनको नंबर डाल के आपको समझाती हूँ. What kind of isomers they are of each other. Let us understand that. Okay. So what kind of isomers? 1 and 2 are of each other. तो 1 and 2 में कार्बन के चेन में फर्क है. What kind of isomers? 2 3 4 are 4 and 5 are of each other. So they differ in position of groups. What will be 1 and 3 or 1 and 4 or 1 and 5? They are chain isomers. Right? What will be 1 and 6, 1 and 7, 1 and 8? They will be chain isomers. So like this we can understand chain isomers. Like this we can understand position isomers. Okay, in the given compound. Now let us go ahead. Before I start teaching you the next isomerism after position, that will be functional isomerism, I need to discuss an important concept called as degree of unsaturation. And this degree of unsaturation helps us in writing the number of isomers possible. जो isomers होते हैं उनका degree of unsaturation जो होता है, okay, must be same. All isomers must have same degree of unsaturation. Okay, so let us start understanding this concept of degree of unsaturation. What does degree of unsaturation means? Okay, it simply means defined as number of hydrogen molecule required to convert a given molecules to a cyclic saturated molecule is called degree of unsaturation. We are understanding the use. So DU का definition is the number of hydrogen molecules required to convert the given compound to convert the given molecule to a cyclic saturated molecule. Yeah, we can say degree of unsaturation is sum of number of pi bonds and ring. दूसरा definition हो सकता है, this is nothing but sum of number of pi bonds and ring. Present in the given compound. तो कुछ एग्जांपल लेके समझते हैं what it is, कैसे समझेगा. तो suppose I take प्रोटीन, दो में से कोई भी एक डेफिनेशन आप यूज कर सकते हो, आंसर दोनों से सेम ही आएगा. So if I go for the first one, I need to know number of hydrogen molecule required to convert this compound into a cyclic saturated. So what is saturated? I need to add 1 mole of hydrogen and I will get 4. So how many moles of hydrogen I have added? 1 mole. तो इसका du क्या होना चाहिए? इसका du होना चाहिए 1. और दूसरे डेफिनेशन से भी आप देखेंगे कि एक पाई बॉन्ड है और क्योंकि एक पाई बॉन्ड है इसका भी du क्या होगा? 1. तो कैसे भी डेफिनेशन से आप देख लो, आंसर इसका 1 ही आएगा. Okay, suppose I give you this, I'm giving some compounds and let us understand calculating. So I give you this ring, a cyclopropane ring. Now the du should be 1 as sum of number of pi bonds and ring. एक ring है तो इसका du 1. हाइड्रोजन वाले डेफिनेशन में क्या करेंगे? साइक्लोप्रोपेन से प्रोपेन बनाने के लिए I just need 1 mole of hydrogen and the du for this also becomes 1. The next one is cyclobutene. तो cyclobutene में कितना du होगा? There is 1 ring and there is 1 pi bond. The du for this compound is 2. Okay, so I need 1 mole of hydrogen to make it saturated and to break it and convert it into N-butane. I will need 1 mole. So this is what is your du. अभी du से कोई फॉर्मूला दिया है तो हाउ टू वी कैलकुलेट du, वो भी मैं आपको समझाती हूँ. सो वन मेथड इज दिस. किसी कंपाउंड का हमने du कैलकुलेट कर लिया तो क्या क्या आइडिया आती है? व्हाट डज du स्टैंड्स फॉर? डिग्री ऑफ अनसैचुरेशन अगर 1 है इसका मतलब क्या है? डिग्री ऑफ अनसैचुरेशन अगर 1 है तो वो जो आइसोमर है मे बी उसमें एक रिंग है or maybe it's a compound having got pi bond. That is what is the meaning of du. अगर du 0 आ रहा है तो du 0 का मतलब क्या है? There is no pi bond and there is no ring. अगर du 2 आ गया तो maybe there are 2 pi bonds, maybe there are 2 rings, or maybe there is 1 pi bond and 1 ring. And like this, various possibilities are there. Apart from this, there is a formula to calculate du. जो मॉलिक्यूलर फॉर्मूला देख के हम du का कैलकुलेशन कर सकते हैं और उसके बेसिस पे कंक्लूजन निकाल सकते हैं. So you can have degree of unsaturation as equal to 2n plus 2 minus number of monovalent atoms upon 2. Okay, so I'm giving you another formula for TU जिसमें अगर molecular formula दिया होगा किसी हाइड्रोकार्बन का तो हम कैलकुलेट कर सकते हैं. So this is 2n plus 2 minus number of monovalent atoms there upon 2. Okay. Abhi, what I was telling you is by using this formula, the answer of DU comes 0. So what is the meaning of DU coming 0? DU coming 0 का मतलब होता है no pi bond, no ring. अगर DU का आंसर 1 आ गया तो उसका मतलब होता है 1 pi bond and 1. DU का आंसर 2 आ गया उसका मतलब 2 pi bond और 2 rings और 1 pi bond and 1. And like this we can go on computing. Okay, जैसे DU का आंसर आ जाएगा और उस हिसाब से फिर हम नंबर ऑफ आइसोमर्स के स्ट्रक्चर में अलग अलग स्ट्रक्चर्स ड्रॉ कर सकते हैं. ओके, ये जो फॉर्मूला मैंने दिया, व्हाट इज n हियर? n इज नंबर ऑफ कार्बन एटम्स. तो जितने भी कार्बन एटम्स है ओके वो n है. Okay, so I'm going ahead. What is the main thing that you have to understand in DU? DU का बेसिक क्या है? कोई भी आइसोमर अगर होगा तो आइसोमर के लिए डिग्री ऑफ अनसैचुरेशन मस्ट बी सेम. So why are we learning it? Because when we are drawing different isomers, their DU is going to come same. For isomers, degree of unsaturation must be same. Compounds are isomers of each other, they must have degree of one unsaturation exactly what same. अगर कोई हेटेरो एटम प्रेजेंट है तो उसके लिए भी हम DU का फॉर्मूला दे सकते हैं. तो मैं और एक DU कैलकुलेट करने का फॉर्मूला देती हूँ, दैट इज C प्लस एक्स माइनस H प्लस एक्स माइनस n अपॉन 2. यहाँ पे C क्या है? C नंबर ऑफ कार्बन एटम. तो ये अभी जो फॉर्मूला दे रही हूँ ये कभी हम यूज कर सकते हैं जब ये हाइड्रोकार्बन नहीं होगा. वी सी अदर हेटेरो एटम्स. This is the formula. So in this formula. C is number of carbon atoms. And N is number of nitrogen atom. तो इस फॉर्मूला के लिए मैं एक दो एग्जांपल्स सॉल्व करवा देती हूँ. So suppose I give you formula C3H6O. So let us substitute in this and solve calculating the C3H6O. कार्बन हो गया 3 प्लस 1 हो जाएगा, है ना. और फिर क्या करेंगे हम उसके आगे. ओके, हाइड्रोजन का नंबर कितना है अपने पास? 6 है. So number of hydrogen is 6 and that is upon 2. और ये ऑक्सीजन का नंबर उससे क्या करना पड़ेगा, मुझे माइनस करना पड़ेगा. माइनस 6 5 प्लस 1 जो है आपका, ये हो गया 4 माइनस 6 5 हो गया 3. तो इसके डी का आंसर आ गया 1. व्हाट इज 1 टीयू? 1 टीयू का मतलब है जो भी कंपाउंड है उसमें एक पाई बॉन्ड हो सकता है या वन रिंग कैन बी प्रेजेंट. दैट इज व्हाट इज du इक्वल्स टू 1. राइट. सो आई एम पुटिंग सम कंपाउंड्स ऑन द बोर्ड. आप उसका du कैलकुलेट करके मुझे बताओ. So another I'm calculating here C7H8O. Tell me the du. And I'm putting some more compounds this side. As we go ahead, I'll teach you the application. कैसे ये du calculate करके use करना है, ये हम सीख लेंगे as we go ahead. Just write du everywhere. Du चाहिए. It's very simple actually calculating du once you have understood the concept. अगर मॉलिक्यूलर फॉर्मूला दिया है तो वो दोनों फॉर्मूला मैंने दे दिए. स्ट्रक्चर दिया है तो बहुत सिंपल. स्ट्रक्चर देने के बाद हमको क्या करना है, सिर्फ we have to go on counting number of pi bonds and number of rings, and that is what will give us the du. Right. So obviously यहाँ पे आ जाएगा हमारा 7 plus 1, that is 8 minus 8 by 2, that is 4. 8 minus 4 हो जाएगा 4. ये जो भी कंपाउंड है इसका du क्या है, 4. Okay, this is the compound which will have du 4. This degree of unsaturation clear to everybody? Okay, जो aromatic rings होते हैं, benzene ring, इसका du क्या आ जाएगा, 4. That C7H8O is most probably a aromatic compound. Okay, here what will be the du? 1, 2 and 3. Du will be 3. Here what will be the du? Du will be 2. 2 rings that I see. The du is going to be 2. Okay, so I just explained you the du concept which we will be using as we go ahead. Now what next are we doing? We will understand the next kind of isomerism, that is functional isomerism. So we can start now with functional isomerism. So what are functional isomers? Compound having same molecular formula, but the structure is different with respect to presence of functional group. So molecular formula same, but functional group will be different. So I will give you, okay, some functional groups in organic chemistry, which are different functional groups, but they share same molecular formula. And then obviously they are functional isomers of each other. So to begin with, पहला formula मैं discuss कर रही हूँ, alkenes and cycloalkenes. So alkenes and cycloalkanes, they share a formula CnH2n. So if I take N3C3H6, so with this formula there is a key propene, and there is a cycloalkane also with the same formula, which is cyclopropane. So what are they of each other? They are functional isomers of each other. The next formula C4H8. So I will have a 4-carbon alkene and a 4-carbon cycloalkane. What are they of each other? Functional isomers. Next category, alkynes and alkadienes. So the general formula will be CnH2n minus 2. This is the general formula for alkynes. This is the general formula for alkadienes. Let us take one and check. So I take a formula C4 and H will be 6. So alkyne C4H6 says this, and alkadiene C4H6. So 2-butyne and 1,3-butadiene, they both are functional isomers of each other. Okay, next set of formula I'm taking is alcohol and ether. So alcohol and ether have same molecular formula. So I take the formula C2, then it will be H6O. So 2-carbon alcohol, C2H5OH, and a 2-carbon ether, CH3OCH. Or C4H10O. So I will have a butyl alcohol. And I have a diethyl. So this is alcohols and ether. Next formula is aldehydes and ketones. They are functional isomers of each other with the general formula CnH2nO. So if I'm taking C3H6O, so with this formula, I'll be getting a 3-carbon aldehyde and a 3-carbon ketone. Four-carbon aldehyde and 4-carbon ketone. Aldehydes and ketones are functional isomers of each other. So copy this, I'll show you some more pairs. So I'm clearing this side of the board. So suppose I give you a formula here C3H6O. Can you try writing the total number of isomers with this formula? तो जिसमें आपको समझना है कि ये फॉर्मूला के आपको अल्डिहाइड, कीटोन और भी जो पॉसिबल कंपाउंड्स पॉसिबल लगते हैं सबको लिखना है with the formula C3H6O. So asking you a question on this formula that I have written. तो एक अल्डिहाइड और कीटोन तो हमने देख ही लिया, और क्या पॉसिबल हो सकता है? अगर आप ध्यान से देखोगे तो अल्कोहल और अल्डिहाइड कीटोन में जो फर्क है वो 2 हाइड्रोजन का है, मतलब can write a alcohol with a double bond, and that will also have same iit-jee H6O distance. So one is a 3-carbon aldehyde, a 3-carbon ketone, and I was telling you now I can put a double bond and write alcohol here. So I can have CH2 double bond CH CH2OH, and this will also have same formula C3H6O. Now the minute I write this double bond wala alcohol, I know alkene and cycloalkanes are functional isomers. So I can put this also. और alcohols और ether functional isomer है, का मतलब डबल बॉन्ड वाला ether भी आ सकता है. और क्या आ सकता है? तो ether में वेरिएशन अभी देखो. Cyclic ether like this also can come C3H6O, and it can be like this also. So I think I've covered all number of isomers. You will see as less as 3 carbons. Look at the possible variation, okay, that we can get for number of isomers. तो इसमें अगर कार्बन नंबर बढ़ गया तो नंबर ऑफ आइसोमर्स एक्सपोनेंशियली बढ़ जाते हैं. ओके, अपने क्वेश्चन जो एग्जाम में पूछ जाते हैं नंबर ऑफ आइसोमर्स के, तो मैक्सिमम 4 या 5 कार्बन के ऊपर नहीं जाते. तो नेक्स्ट फंक्शनल ग्रुप दैट आई एम डिस्कसिंग, okay, which are functional isomers of each other, is acid, ester, and hydroxycarbonyl compounds, and they all have same general formula CaH2NO2. So I'm clearing this side. और नंबर कितना था? Suppose I take 3 carbons, H6O2. So I will have a carboxylic acid of 3 carbons and a ester with 3 carbons. Or I can write a format ester. Carboxylic acid and ester are functional isomers of each other. They are having same molecular formula, but they do have different functional group. इनके साथ में हाइड्रोक्सी कार्बोनिल मतलब अल्डिहाइड या कीटोन के साथ OH ग्रुप भी यही फॉर्मूला देता है. कार्बन हाइड्रोक्सी कार्बोनिल ग्रुप. तो ये हाइड्रोक्सी कार्बोनिल 3 कार्बन वाला आ जाएगा. और एक कीटोन वाला all these compounds on the board, they all are C3H6O2, acid, ester, and hydroxy carbonyls. are functional isomers of each other. Next functional isomers are amines. So amines में primary amine, secondary amine and tertiary amine are functional isomers of each other. So the general formula for amine, I take C3, then H will be 9 and N. C3, H9N, 3 carbon wala amine. So what are the isomers here? I can have a primary amine, this CH3, CH2, CH2, and H2. Can have a secondary amine, so they are functional isomers of each other. ये छोड़ के cyanides और isocyanides, तो इनका जनरल फॉर्मूला है CnH2n minus 1n. Same formula, we can get a cyanide, same formula, we can get a isocyanide. Say I'm having C3, H5, this will be CH3, CH2, C triple bond. This is cyanide, and on this formula, CH3, CH2, and triple bond C. So cyanides and isocyanides are functional isomers of each other. Nitroalkanes and alkyl nitrides. The next category, so nitroalkane is this functional group NO2. This is nitroethane. And alkyl nitride will be C2H5ONO. ये हो जाएगा ethyl nitride. Then your aromatic alcohols and phenols are functional isomers of each other. So I'll give you examples. Say benzyl alcohol. And a cresol. And that also metal para any position. So what are these two of each other? These two are functional isomers. Alcohol is a different functional group. Phenol is a different functional group. We are going to understand them as we go ahead. Then next will be oximes and amines. So I take a carbonamide, acetamide, CH3, CO, NH2. Now what is the oxide? CH3, C, double bond, C, H, N, double bond, whiche. So we get this compound. Okay. This is oxide. And the two compounds that I have written on the board, they are functional isomers of each other. This is the amide and another one is oxide. Last in functional pair, I'm discussing thioalcohols and thioethers. This is the thioether. And this is the thioalcohol. What are they of each other? Functional isomers. Right, so that finishes functional isomerism. I'm discussing the next category, ring chain isomerism. What is ring chain? You will see one compound cyclic, one isomer is cyclic, and another will be acyclic. Isomerism number 4 I'm discussing, and that is ring chain isomerism. रिंग चेन में एक आइसोमर आपका रिंग होगा तो उसका दूसरा आइसोमर एलिफैटिक चेन होगा, तो ये डेफिनेटली हमेशा क्या होंगे, फंक्शनल आइसोमर भी होंगे. से फॉर एग्जांपल आई टेक द फॉर्मूला C3H6, इसमें ये हो गया प्रोपीन और ये हो गया साइक्लोप्रोपीन, which I give you as an example of functional, but they are also called as what, ring chain. Or if I take a formula C3H4, so 3 carbon alkyne, and maybe cycloalkene. What are they of each other? Functional isomers, right? So ring chain में what are we going to get is, in ring chain we are getting one compound ring, then another compound will be chain. Okay, chain मतलब normal आपका क्या हो जाता है, aliphatic and cyclic. If they share same formula, then they will be called as ring chain. They are always, ring chain is always functional. Ring chain isomer is always a functional isomer, but reverse to नहीं, सारे functional isomers ring chain नहीं होते. As I have given you so much variation in function. I am discussing the last isomerism for today, that is metamerism. जो tautomerism pending है वो हम अगले fresh lecture में करेंगे. So what is metamerism? What are metamers? How do we identify metamers? So metamers are the compounds that we get only when we are having a polyvalent functional. So definition is the compound having different alkyl group attached to same polyvalent function. Compound having different alkyl group attached to say polyvalent function. So for example, polyvalent मतलब क्या? OH अगर मैंने लिया अल्कोहल तो वो मोनोवैलेंट है, but look at ether. Ether is polyvalent. क्या ये आपका कार्बन ईथर ये polyvalent? क्या secondary amine, tertiary amine are polyvalent? These are some polyvalent functions. And yes, ester is a polyvalent function. ये ऐसे टाइप के अगर फंक्शन है और इनके दोनों साइड पे जो अल्किल ग्रुप से अगर वो चेंज हो रहे हैं तो आपको मेटामेरिज्म मिल जाती है। इसमें आपके जो दो आइसोमर्स होंगे they will be of the same homologous series. So we can say compound having same molecular formula but difference in structural formula due to different alkyl groups on either side of the functional group is called metamers. अभी मैं ether का example ले रही हूँ ROR. तो molecular formula same होगा but आपके alkyl group बदलेंगे. So C4H10O. So I can have this ether ethyl diethyl ether, and I can have a metamer of dimethyl ether, a diethyl ether, which will be N-propyl methyl. What are they of each other? Metamers. So what is the difference? Around the polyvalent functional group, the alkyl groups that are attached, they are different. Here two ethyl that you see, here you see one propyl and one methyl. So around the polyvalent functional group, if arrangement of alkyl group is different, then that is what is pure metamers. So next example I am giving you is of ketone. Suppose I am having C5H10O. So C5H10O will be C2H5, C double bond O, C2H5. And same CH3, CH2, CH2, C double bond O, C2H5. So around the arrangement of alkyl here is different. A similar example I can give you of secondary amine. Okay, I can give you example of secondary amine also. So secondary amine means I'm having a secondary amine dimethyl amine. And a metamer of that where I change the alkyl group and write N-propyl methyl amine. Right? So these are what are called as metamers. So that's it for today's lecture. I'm stopping at metamerism and we will start with tautomerism. Tautomers understand करेंगे structural isomers के सबसे important जो isomers है सबसे important isomerism structural की tautomerism है. Okay, so that's what we will try understanding from next lecture. Lecture 2 will be tautomerism for isomerism. That's it for today. See you next time. We continue with isomerism. That is mainly we will be discussing tautomerism.